Hi guys, have you ever opened any electronic device like your phones, your laptops, your chargers, inverters, MRIs, drones, robots? Basically any electronic device you can think of contains a board inside them which is mostly green in color, where all the components that makes this device work are mounted upon. This board is called a printed circuit board or PCB. With its use case in every electronic device, it is no doubt that PCB is a primary backbone and a fundamental building block in the electronics industry. Let's talk about PCB and PCB design. What is a PCB? A PCB, in simple terms, is an insulated laminated board with conductive copper pathways where all the electronic components are connected together if mounted upon this board. In other words, instead of using wires, breadboard, variable to make electrical connection between components like microprocessors, microcontrollers, capacitors, resistors, diodes, transistors, you can use a PCB which has all the connections done inside the board, and all you need to do is to mount the component on this board. This is extremely useful considering that electronics has become miniaturized such that using wires has become impractical, impossible, and can lead to errors. We know the reason why we need PCBs. Therefore, how can we make them? This is where PCB design comes in. PCB design is basically using electronic card software such as KeyCard, Altium, EasyEDA, DeepTrace to design these boards. And you can further send this board to a suitable manufacturer, or you can make them yourself, which to me is a limited approach and cannot be used for complex designs. As someone who has used different PCB design softwares, I recommend for beginners who want to get into PCB to use either KeyCard or EasyEDA because they are beginner friendly and easy to use. Regardless of any PCB design software that you're using, it has three phases of design approach, which is the schematic layout, the PCB layout, and the 3D view. The schematic basically is a blueprint of how the connections should be. Whatever PCB you are making has a schematic of how the connections of the PCB should be, using electrical symbols to what? To create the connections for the PCB. Once you are done with the schematic, you then convert your schematic into PCB. PCB contains footprints, traces, the board outline, everything that consists of how the board should be in real life after manufacturing. After doing your PCB, you can view it, the 3D model in the 3D viewer. The 3D model shows you how your board would look like after it is manufactured. These three phases are very important when designing PCBs. On everything, you can do your design rule check to confirm if your board obeys every manufacturing capabilities. After that, you can give your board to a suitable manufacturer like JLC PCB for instance, or PCBWay, Next PCB to manufacture your board for you. Or you can do it yourself, like I said earlier, which it is a limited approach and impractical. And I don't think you can do it for complex layer boards. You can do it for that. For instance, I did a PCB design of an IR proximity sensor. As you can see, this is the schematic layout. You can see these symbols of every electronic component. Later, I converted it to PCB and did the routing of everything, the board outline, and you can also see the 3D view of the design as well. After that, I was able to manufacture it from JLC PCB. It was quite cheap using their manufacturing service as well. When starting PCB design, there are a lot of YouTube tutorials you can watch. There are tons of them out there. But personally, I prefer videos from YouTubers like Robert Ferranak, Philip Samoni, and Ted Edkish. Their videos are very great when getting started with PCB design. From my point of view, PCB design is not that complex if you only design two-layer boards and four-layer boards, where the four-layer boards, the two inner layers are plain layers for ground and VCC. However, if you want to take a professional route towards PCB design, either as a career path or you want to design high-speed boards or boards whereby signal integrity is very important, or you are building an hardware product, PCB design requires you to have knowledge in signal integrity, design for manufacturing, electromagnetic interference, board layer stack up, and as well as knowing the IPC standards. IPC standards in general are industry standards that PCB design should meet when in the industry. Not just PCB design alone, but PCBs as well. The way the PCB is formed for industrial purposes is very essential. And yeah, PCB design as a career path has been in my mind lately because there are less discussion. It still needs room for more discussion about PCB design as a career path. Also, in school, I've seen some final year projects whereby students make hardware devices and they use breadboard and vero boards for their projects when they can basically use PCB. And that have been bothering me as well because in school they don't really teach PCB design. I've right now I'm in my fourth year right now and I've never taken a course of PCB design. Everything was personal learning. So it's really interesting to see that, but still it's sad as well because PCB design as a career path is very, very crucial. And like I said, it needs more light in it for real. A lot was not discussed in this video. I didn't go into one of the major um, factors in creating PCBs, your routing style, VR styles, your board outline, copper pole, and things like that. So I believe one should make their own research. Yeah, please don't forget to like, share, and subscribe. And in the end, hardware is peak. Thank you.